Hello guys, welcome to another video on GD&T. In this video, we'll be exploring alternate GD&T schemes. So let's say if you're having a component and if you're making a GD&T scheme for a component. Now a GD&T scheme is made based on the functional importance of the features. So basically we analyze what are the features in a component and then we allocate the primary, secondary, tertiary datums to components, and then we find out which features or features of size need to be controlled with respect to what. So based on these rationales, we come up with a GD&T scheme. Now we can have multiple number of GD&T schemes for the same component. That is what we will understand in this video. So let's say if you are having a component like this and this is one possible GD&T scheme for it. So let us understand that. So there are three views here. And this surface over here is given as primary datum feature, and it is being controlled with respect to its parallelism within a tolerance zone of 0.08. So this part is having a center hole over here, a large center hole over here, a planar surface on top, and then there are two holes here which are through holes on the side. So this is a flat surface and so is it on the opposite side. So the primary datum feature is this top surface, and that is being controlled with respect to flatness within a tolerance zone of 0.08. Then we go to this center hole. This center hole is being controlled with respect to its perpendicularity within a cylindrical tolerance zone of 0.2, which means that the axis of this hole should be within a tolerance zone of 0.2, a cylindrical tolerance zone of 0.2, located over here, and that tolerance zone is going to control the perpendicularity of that axis with respect to datum feature A. That means that the axis of this hole should be perpendicular to the datum feature A, and this hole, which is a feature of size, is secondary datum feature, which is datum feature B. The size of this hole is 15 with the size tolerance of plus or minus 0.1. And we have another feature of size, which is this width, 32 plus or minus 0.2, that is a tolerance on that width. That is the width of this part, 32. And that width is being controlled with respect to its position. Now when we apply position on a width feature of size, it means that the center plane, the center median plane of the width. So if you take a line over here, a line over here, and then we have a line over here, that line is center plane of these two surfaces. That center plane should lie within a tolerance zone of 0.2. So basically there will be a rectangular tolerance zone of 0.2 and the center plane is equally spaced with respect to that tolerance zone. So it can move up or down 0.1, 0.1 on either side with respect to the center. So the center plane is being controlled of this width with respect to datum A and B. So one, it is being controlled with respect to datum A with respect to its perpendicularity, that is inherent control, and also with respect to datum B, that is the center axis, the position is being controlled. So there are two things being controlled over here. One is the position of the plane, center plane with respect to the axis of the hole, that is datum B, which is, and also the perpendicularity of that plane with respect to datum feature A, which is this surface. So when we use position tolerance, orientation control is automatically inherent inside the position control. So this is an important thing to note whenever we are applying position control on features of size. So let's have a look over here on this view. So here the depth of the hole is given. So the depth is 20 plus or minus 0.25. And then there are two holes. The cut section view here shows two holes. And these two holes with the size of 6 plus or minus 0.1 tolerance, size tolerance, are controlled with respect to their position within a cylindrical tolerance zone of 0.3 with respect to datum A, B, and C. So with respect to datum A, which is this surface, datum B, which is this hole, and datum C, which is this width, this position of these holes is being controlled within a cylindrical tolerance zone of 0.3. And additionally, there is another control which has been applied over here. The width, the internal width, the cavity of 20 plus or minus 0.2 is being controlled with respect to its position with respect to datum B. So with respect to this center axis, this width is being controlled. We are saying that this width should be symmetrical with respect to the center axis of the hole. So that is what we are controlling over here, the position of the width with respect to the hole, because here datum B is the one which is mentioned. So datum B is the hole. So that is what is being controlled. Now this is one possible GD&T scheme. Now let us have a look at another GD&T scheme. Here is scheme 1, which we have seen, and on the right hand side is an alternative scheme. So let us have a look at that alternative scheme. Now let's have a look at an alternative scheme and understand the differences. So the part remains the same. Only thing is the way in which GD&T has been applied has changed. So let us see what has changed. First, let us have a look at the primary datum feature. Now in the scheme 1, the base scheme, the primary datum feature was this surface. Over here, the primary datum feature is a feature of size which is this width. So this surface and this surface on either side form a width, and this is specified as 32 plus or minus 0.2. So the width is a feature of size which is primary datum feature in the alternate scheme. And then if we search for the secondary datum feature, we find that the two holes, the small two holes of dia 6 are secondary datum feature, and the two holes are being controlled with respect to their perpendicularity within a cylindrical toroidal zone of 0.2 with respect to datum A. So datum A is nothing but datum feature A is a feature of size which is width. So basically we are controlling the orientation, the perpendicularity of the axis of the holes with respect to the center plane of the width. So this line indicates the center plane of the width, and we are controlling the perpendicularity of these two holes with respect to this center plane. That is what we are controlling, and this is datum feature B. Now in the first scheme, the primary datum feature was this top surface as shown over here. Here that top surface is now tertiary datum feature C, and datum feature C, that is this surface, is being controlled with respect to its parallelism. So here we are controlling the parallelism of the surface, and the basic dimension for controlling that parallelism is shown over here, which is 36. So in the scheme 1, we had this basic dimension which was locating the hole with respect to datum feature A. But here we are locating the surface, or we are controlling the parallelism of the surface with respect to the hole. So it has reversed. You can see how the change in scheme will change the way in which the surfaces or features are being controlled. So here we are controlling the top surface with respect to the holes. Over here we are controlling the hole with respect to the top surface. So it has reversed. The depth of the hole, that specification remains the same as in scheme 1. But the control of the internal width feature of size, which is this one, specification 20, that is a size 20 with a size tolerance of plus or minus 0.2, that is being controlled with respect to its position, or you can say with respect to its symmetry with respect to datum A. So datum A is the width feature of size 32. So we are controlling the position of the center plane of this center width with respect to the center plane of the outer width. So that is what is being controlled. The location of the inner width center plane is being controlled with respect to the center plane of the outer width, which is having the size of 32. So that is different from scheme 1. In scheme 1, this internal width we were controlling with respect to this center hole. Now this internal width location is being controlled with the external width location. External width. So that is the difference. Next, this hole, the hole on the top, which was feature of size, datum feature of size B in scheme 1, that hole is being controlled with respect to its position within a cylindrical tolerance zone of 0.2 with respect to datum A, B and C. So this hole is being controlled with respect to its position with respect to the other features, datum A, B and C, and the size of that hole is 15 plus or minus 0.1. So that remains the same. So here you can see the difference in the scheme. In scheme 1, this hole was a secondary datum feature, but in scheme 2, which is alternate scheme, this hole is no longer a datum feature, whereas it is being controlled with respect to other datum features in the component. So we can understand the differences between the two schemes by understanding the primary and secondary datum features which have been selected in both the cases. So in the first case, in scheme 1, the planar surface is selected as the primary datum feature. Now this would be a case in which this surface is much more important, functionally important as compared to the width. So when the planar surface is coming into contact in assembly first, then this has to be selected as the primary datum feature. But if the width, the external width feature of size is coming into contact in assembly, or it is more important in terms of its function of the component, then this width feature of size has to be selected as the primary datum feature. And secondary datum feature, the hole has been selected in the first scheme, the feature of size hole, whereas in the second scheme, the two holes, the pattern of two holes which are feature of size have been selected as secondary datum feature. Again, that depends on the functional importance, whether this hole is functionally more important as compared to these two holes, whether the location or in manufacturing, the two holes are being manufactured based on the location of this hole and this surface. If that is the case, then scheme 1 makes more sense. But if these holes are first made after the width has been manufactured, or the center hole is made with respect to the two holes, then the alternate scheme makes more sense. So depending on the manufacturing and the functional importance of the features of size, the appropriate scheme has to be selected. So basically selecting a GD&T scheme is based on the functional importance of that surface and how stable the part will be if it was held with respect to that surface or not. So the primary and secondary datum features and even tertiary are selected based on these criteria. How functionally important are those surfaces to the part, and how stable is the part when it is being held with respect to those surfaces. So based on that, we can select the scheme which is appropriate.